This morning at 7:47 a.m. Eastern Time, something extraordinary happened in our solar system. While most of Earth slept, an interstellar visitor the size of Manhattan reached its closest point to the Sun, hidden from our telescopes behind the solar glare. Harvard astrophysicist Dr. Avi Loeb calls today the acid test that could determine whether we're witnessing a natural comet or something far more profound. This is the story of 3I Atlas, and why the scientific community cannot stop talking about what happened today. On July 1, 2025, a telescope in Chile's Rio Hurtado Valley detected a faint, fast-moving object unlike anything astronomers had seen before. The Asteroid Terrestrial Impact Last Alert System, designed to spot potential Earth threats, had stumbled upon the third confirmed interstellar object ever observed. Named 3I Atlas, this visitor was racing through space at an astonishing 130,000 miles per hour, carrying secrets from another star system. But this was no ordinary cosmic wanderer. Within weeks, telescopes around the world would reveal characteristics that challenge everything we thought we knew about objects from beyond our solar system. Dr. Avi Loeb, former chair of Harvard's Astronomy Department and director of the Institute for Theory and Computation at the Harvard-Smithsonian Center for Astrophysics, has dedicated his career to asking humanity's most profound question: are we alone? When data from 3I Atlas began arriving at his desk, the veteran scientist immediately recognized patterns that didn't fit natural explanations. Loeb created what he calls the Loeb Scale, a ranking system from 0 to 10 that measures how likely an interstellar object is to be technological rather than natural. A rank of 0 means definitely natural. A rank of 10 means definitely artificial. 3I Atlas earned a rank of 4, based on 8 anomalies that have left the scientific community deeply puzzled. The first anomaly concerns trajectory. When objects enter our solar system from interstellar space, they typically arrive from random directions, reflecting the chaotic nature of galactic motion. But 3I Atlas follows a path aligned within just 5 degrees of the ecliptic plane, the flat disk where Earth and other planets orbit the Sun. Loeb's calculations show this alignment has a probability of only 0.2% if the object arrived by chance. Even more intriguing, its approach vector originated from near the galactic center, making early detection extremely difficult against the bright stellar background. By the time astronomers spotted it, launching an intercept mission was already impossible. The second anomaly appeared in images from the Hubble Space Telescope in July. Unlike every comet humanity has ever observed, 3I Atlas displays what scientists call an anti-tail, a jet of material pointing toward the Sun rather than away from it. Standard comet physics dictates that solar radiation pressure pushes gas and dust away from the Sun, creating the classic tail we see in textbooks.
Yet 3I Atlas defies this fundamental principle.
The jet aims directly at our star, suggesting forces at work that current models cannot explain. Then came the chemistry. In August, the Keck-2 telescope in Hawaii analyzed the spectrum of light coming from 3I Atlas's surrounding cloud. What the team found sent shockwaves through the astronomical community. The object was emitting nickel at a rate of nearly 1 gram per second, but showed absolutely no trace of iron. This is unprecedented. Every comet, asteroid, and interstellar object previously studied contains both nickel and iron together, reflecting the cosmic abundance of these elements formed in stellar explosions. Finding nickel without iron is like finding smoke without fire. But the story gets stranger. The nickel wasn't just present. It was forming a specific compound called nickel tetracarbonyl. This molecule, with the chemical formula NiCO4, is toxic, volatile, and exclusively known from human industrial processes. On Earth, we use it to refine and coat metals in high-temperature aerospace applications. The compound has never been observed naturally in space. Dr. Loeb stated plainly to reporters, "There is only one place where that is known to exist, and that is in industrially produced nickel alloys." This was a process that we can imagine only because it was used in industry, never seen in comets before. The third major anomaly concerns mass and velocity. 3I Atlas is approximately 1 million times more massive than Oumuamua, the first interstellar object discovered in 2017, and 1,000 times more massive than 2I Borisov, discovered in 2019. Despite this enormous mass, it travels faster than both previous visitors. This combination challenges models of how interstellar objects form and travel through the galaxy. The fourth anomaly involves non-gravitational acceleration. Tracking data shows 3I Atlas is speeding up and changing course in ways that gravity alone cannot explain. While comets can accelerate due to outgassing, the observed changes don't match expected patterns for a natural comet of this size and composition. The fifth through eighth anomalies form a pattern that Loeb finds particularly concerning. The object's arrival time was perfectly tuned to bring it within tens of millions of kilometers of Mars, Venus, and Jupiter, with a calculated probability of just 0.05%. Its orbit is retrograde, moving opposite to the planet's direction, which offers tactical advantages for approach and observation. Most significantly, today's perihelion occurred when Earth is on the opposite side of the Sun, making 3I Atlas completely unobservable from our planet during what spacecraft engineers call the optimal moment for maneuvers. In astronautics, this is known as the Oberth effect. When a spacecraft wants to change velocity most efficiently, it burns fuel at perihelion, the point of closest approach to a massive body. The high orbital velocity at that point maximizes the kinetic energy gained or lost from the maneuver. If 3I Atlas were an artificial probe, today would be the ideal time to execute course corrections, deploy smaller craft toward planets, or perform other technological operations, all while hidden from Earth-based observation. Loeb, along with co-authors Adam Hibbard and Adam Kroll, published a paper titled "Is the Interstellar Object 3I Atlas Alien Technology?" The paper, while primarily pedagogical, seriously examines whether 3I Atlas could represent what's called the dark forest solution to the Fermi paradox. This theory suggests advanced civilizations remain silent and hidden because the universe is dangerous, with aggressive species eliminating any civilization that reveals itself. If correct, an interstellar probe might be reconnaissance for a hostile force. To be clear, Loeb emphasizes repeatedly that 3I Atlas is most likely a natural comet of unusual composition. But he argues that black swan events, rare occurrences with massive implications, must be taken seriously even when their probability is small. The stakes for humanity are too high to dismiss possibilities based solely on their unlikelihood. The scientific establishment has responded with a mix of fascination and skepticism. NASA officially states the object poses no threat to Earth and shows no credible evidence of artificial origin. The space agency points out that unusual chemistry can result from rare but natural processes in other star systems. Perhaps 3I Atlas formed in a metal-rich debris field from a planetary collision, or experienced unique evolutionary processes during its billions of years traveling through interstellar space. Other researchers suggest that the nickel tetracarbonyl might form through previously unknown natural pathways. The object's extreme age, estimated at 7 billion years, means it has experienced cosmic environments we barely understand. Some scientists propose that ices, exposed to cosmic radiation for eons, could develop chemical shells where unusual molecules form and later sublimate when heated by our sun. The controversy extends beyond scientific journals. Dr. Loeb's willingness to publicly discuss alien technology hypotheses has drawn both admiration and criticism. Supporters praise his courage to ask unconventional questions and challenge scientific orthodoxy. Critics argue he gives undue attention to low-probability scenarios and contributes to public misunderstanding of science. A YouTube channel with millions of subscribers has called him a fraud, while Reddit forums host lengthy debates about his credibility. Yet Loeb remains undeterred. In interviews from his Lexington home, he speaks passionately about preserving childhood curiosity and refusing to let peer pressure dictate which questions scientists are allowed to ask. He worries that academia incentivizes conformity over creativity, and that young scientists learn to avoid controversial ideas rather than pursue truth wherever it leads. Every morning he jogs 3 miles at sunrise, thinking about the cosmos and humanity's place within it. The International Asteroid Warning Network, a global collaboration coordinating planetary defense efforts, has announced a dedicated observation campaign for 3i Atlas running from November 27, 2025, through January 27, 2026. This decision follows a white paper Loeb submitted to the United Nations in September, advocating for coordinated international monitoring of interstellar objects that could pose technological threats. The UN document argues that while such scenarios are unlikely, their potential impact on humanity justifies serious preparedness. U.S. Congresswoman Anna Paulina Luna wrote to NASA's interim administrator in July, recommending that spacecraft near Jupiter attempt to intercept 3i Atlas during its March 2026 flyby. Loeb's calculations showed that NASA's Juno probe, if it still had its original fuel supply, could have reached the object. However, after years operating in Jupiter orbit, Juno lacks sufficient propellant for such a mission. The Mars Reconnaissance Orbiter successfully photographed 3i Atlas in early October when the object passed within 12 million miles of Mars. These images, captured by the high-rise camera with better resolution than any Earth-based telescope could achieve, remain under analysis. Scientists eagerly await their public release, hoping they will reveal new details about the object's structure and composition. The James Webb Space Telescope observed 3i Atlas in July and August, measuring an unusually high carbon dioxide to water ratio in its coma. This finding suggests the object's formation environment differed significantly from conditions in our solar system. The abundance of CO2 might result from cosmic ray bombardment, creating a cooked shell on the surface during its interstellar journey. As 3i Atlas emerges from behind the Sun in the coming days, telescopes around the world will track it closely for any signs of fragmentation, unexpected brightness changes, or course alterations. If the object breaks apart, it would support the natural comet hypothesis, as weak forces holding ice and rock together could fail under solar heating. If it remains intact and continues unchanged, questions will only deepen. The object will pass closest to Earth on December 19, 2025, at a distance of 269 million kilometers, still far too distant for radar imaging with current technology. It will then head toward Jupiter, reaching its closest approach to the gas giant in March 2026. The European Space Agency's JUICE spacecraft and NASA's Juno probe will have opportunities for additional observations during this period. Dr. Loeb continues writing daily essays on his Medium blog, analyzing new data as it arrives and sharing his thoughts on the philosophical implications of interstellar visitors. He acknowledges that many of his predictions will prove wrong, noting that working on the frontier of knowledge requires accepting frequent mistakes. But he believes science advances through bold hypotheses tested against evidence, not through timid avoidance of difficult questions. Whether 3i Atlas is a remarkably unusual comet or something more extraordinary, it represents an invaluable scientific opportunity. This ancient traveler has journeyed through the galaxy for billions of years, carrying information about stellar systems we can never hope to visit. Every measurement teaches us something new about the diversity of objects in the universe and the processes that create them. Today's perihelion marked a turning point in the 3i Atlas story. The coming weeks and months will determine whether this interstellar visitor retains its mysteries or reveals definitive answers. Scientists will continue monitoring, measuring, and debating. Loeb will keep asking uncomfortable questions. And somewhere in the darkness between stars, countless other objects drift through the cosmic void, some of them perhaps heading our way. The truth about 3i Atlas, whatever it may be, reminds us that the universe remains far stranger and more wondrous than our theories predict. And sometimes the most important scientific contribution is simply having the courage to look up and ask, what if?